Hi guys, welcome back to my channel Pirai Academy. In the series of data structure playlist, today we are going to see about what is in the time and space complexity. So basically, this video is one of the video in the data structure, right? So I want you to understand these basics, not in depth. So basics is enough for this whole data structure, okay? And in rather, I can tell you that it is analysis of algorithm, okay? And it is going to be the basics. So what is meant by analysis of algorithm and why we need this analysis of algorithm? Everything in every process, we need some analysis, right? What is in the algorithm? It is step-by-step procedure, a process in other terms. So we always analyze our process. Okay. First, first, why we need this analysis of algorithm? So first the question is why? Why we need this analysis of algorithm? To compare all the algorithms and choose what is the best among them. Can you understand this? For example, there is a process of making something like tea. Okay, there's a process of making tea. There are totally of three steps or three procedures in rather three procedures. Say algorithm 1, algorithm 2 and algorithm 3. Okay, now I ask you which one is efficient. Which one is efficient? Then you will be telling like, hey, the overall efficient is algorithm 3. By doing each and every step in this algorithm 3, I can prepare a good tea. In a simple method or in an efficient way, right? So in this algorithm 1, this algorithm 2, I can also make the T, but it is inefficient way. Okay, for example, if there is a tea shop, okay, there's a local tea shop, then they will be adding more water, right? Right. So, for example, in algorithm 1, you will be adding full milk, and here also you will be adding fully of milk. There will be no water. Whereas here there is a water, then now for the local tea shop, I will be going with this algorithm 3. Algorithm 3. Yes. So now hope you understand why we need analysis of some algorithm. Okay. Now, so this is your real time example. But in case of your CS concepts, okay, the analysis of algorithm is done via some metrics. Okay, how we can compare these algorithms? For example, there are totally three algorithms: A1, A2, and A3. To compare these all, I have some metric. For example, if it is for mobile, then I will be preferring what? Battery performance. Battery performance. Can you understand this? Now, if it is for our personal computers, then I will be preferring time complexity and space complexity. So many of the students, me too, okay, I too, when I am starting this algorithm, I have a misunderstanding. Like the algorithm is always analyzed via time and space complexity, but it is not. But it is incorrect. Okay, because in our entire algorithm we will be going with PCs, our personal computers, but there are other applications also. We can develop a mobile application. While developing your mobile application, you will be preferring the battery performance. If you are writing some algorithm, then that should be battery performance. Can I understand this? So there are some metrics like I told here. For example, this algorithm 2 of making the tea is of very good taste and having much milk. But it is average taste, but there are maximum of water, which means we have efficient profits. So this is used in the local feature. Can you understand this? So this is your example, and this is going to be your exact CS concept. Can you understand this? So I don't want you to make this similar mistake. Okay? Always remember The algorithm is analyzed via many factors, not only with time and space complexity. Hope you understand this. Okay. Now, there are two methods to analyze this time and space complexity. Till now, we didn't get into the time and space complexity. Till now, I told you some misunderstanding and what is in the analysis of algorithm. Now, I want you to understand how we are going to measure time and space complexity so that you can understand the definition of them. Okay, so there are two methods. What are those? One is a posteriori method, and another one is a priori method. Okay, so basically it is a posteriori analysis, and here also it is a priori analysis. Okay, okay. Now let us understand what these two things so that we can go with the definitions. So first of all, in a posteriori analysis, to analyze a time complexity, to analyze the time complexity, we'll be taking the algorithm, some algorithm, and turning it into a code. Turning it into a code, like for example, if it is wrote in a C language, C language. Now I will be executing this. Now I will be executing this. While executing, I will be measuring the time. I will be measuring the time. So here comes the time taken. So this is going to be my time complexity using a posteriori analysis. Can you understand this? Now, in a priori analysis, we will be not doing like this. Why? Why? Because see this carefully. When I am taking the time, it may vary with respect to languages, with respect to process, with respect to all other factors. Can you understand this? So to avoid this drawback, we will be going with a priori analysis using asymptotic notation. Okay. Uh, I also want you to understand what the drawback in a posteriori analysis. See here, in a posteriori analysis, we will be getting the exact time taken. We will be getting the exact time taken. But but if I use something like Python program, then the time taken will be increased for the same algorithm. But we don't want that. We don't want that. See, if I am using a processor, see here, here's me and here's my friend. Okay, I am using advanced processor. While he is using some old processor. Then I am running a algorithm in my system and in his system. This algorithm is same. Now, can you figure out who's going to be finished first and who's going to be finished last? So mine going to be finished first. Then only this will be finished. Finish the execution, right? So from here I can tell you that the processor is also going to be take part in case of a posteriori analysis. But I don't want that. So that's the reason why we will be going with a priori analysis. Now hope you understand why we are not going with a posteriori analysis. Hope so. Okay. Now I want to understand another mistakes that we will be commonly making among the students. Okay, among the students, whenever we are asking some of them with a time complexity, define time complexity, then they will be telling that time complexity is a time taken by the program. No, no, no. It is quite wrong. Okay. Whenever they are asking a question like what is time complexity, then the immediate answer should be like the rate of time with respect to given input. So that's the reason why we are getting into the asymptotic notation. So in asymptotic notation, we have big O, big theta, sorry, big O, big omega, theta, small o, and small omega. But I am not getting into that. I am going to show you how we are going to figure out asymptotic notation with respect to big O notation. Big O notation. That's enough for this data structure. If it is going for the algorithm, then you want to know about these five things. Okay, now I am going to focus on big O. Sorry, I want to focus on this only. That's why I am focusing on this. Okay, fine. So let us take some example program so that it will be clear. Just a second, I will be writing here. Now, For example, this is a given program. Okay. Then how we are going to find what is the time complexity of this program? Fine. So first of all, we are taking a loop here, right? So let me expand this loop. In Java or C, we'll be writing like for j is equal to 0, sorry, I is equal to 0 and I is less than n and I plus plus. So this thing is pseudocode. Meanwhile, here I written a program for better understanding. Okay. Now tell me for this step for initializing how many time I want or how many units I want. Then I will be telling like it is 1 unit. Always remember for initializing and using operators it will be 1 unit. We are not taking 1 millisecond or we are not taking 1 second. We are taking 1 unit of time. No other difference. Okay. Now here comes 1 unit. For initialization we using 1 unit plus. Again, here it is I is less than n. Here we do how many comparison? We will be doing n plus 1 comparison. For example, when I is equal to 0, I will be comparing. Again, when I is equal to 1, I will be comparing. When I is equal to n, again I will be comparing. Then only it will be terminated, right? So this step will be n plus 1 plus. Here comes I plus plus. For this I plus plus, it will be not executed while initializing. After that, for n times it will be executed, right? So plus again plus. This is over. Now we are going to take the next part. What's the next part? This. So let me write here for j is equal to 0, j is less than n, j plus plus. Now tell me what is the initialization here? Here there is only the assignment j is equal to 0. But it is assigned for n times of this loop. Can you understand this? So it means 1 into n. For assignment it will be 1, but it will be again and again this for n times. Can you understand this? Now come here. Here there is less than n, which means plus n plus 1 time this will be executed, but it will be executed again for n times for this I loop. Okay. Again here comes j plus plus, which means n into n. Hope you understand this. Okay. Now this line. So it is like a is equal to I plus j. Now in first itself I told you like wherever the operator is used, whether it's a ternary operator like equal statement or it is like comparison or addition or logical, anything, any operator, then it will be taking a constant time or 1 unit. Okay. Now here comes 1 into for this equal 1 into how many times this equal to will be uh, revoked or this equal to will be used. So here n times and here n times, which means n into n. So 1 into n square plus again this plus symbol also 1 into n square. Now if you simplify this, then it will be something like 4n square plus 4n plus 2. Can you understand this? Okay. Now, so this is your whole time complexity. But we'll be writing this like what is the maximum order? It is n square, right? It is n square. So we'll be writing like big O of n square time complexity. Can you understand this? Right? So I'm not going to get into how this big O is represented or what is the functionality behind this big O. I want you to understand if I use some code like this, then you want to convert this into some other time complexity. We want to predict the time complexity. So that's my main goal for this data structure playlist because it is not the algorithm to analyze it. Here, in this data structure, this time complexity is important when you are going with data structure because you are going with data structures like heap, hash map, arrays. Okay, that we want the time complexity to compare which one is best. Can you understand this? So that it will be useful. So I hope you understand up to this. Now I want you to understand again something like a graph behind this. Okay. Now the time complexity will be in the order of first of all. O of 1. It means constant time. For example, there is a is equal to 1 plus 2 or a is equal to 3. Here, it will be taking constant time. Or there is a if else statement. Then it will be taking as constant time. The overall time complexity of constant will be always smaller value. This will be your best scenario. Will be less than O of log n base 2, less than root n, less than n, less than n log n base 2, less than n square, less than 2 power n, which is less than n factorial. So remember this time complexity order. Okay, always this constant will be lesser than log n. Again, log n is lesser than root of n. Again, root of n is lesser than n, and n is lesser than n log n, and n log n is lesser than n square, n cube, n power 4, and 2 power n will be larger than that, and n factor will be larger than that. 2 power n. Can you understand this? So always know this order. In analysis of algorithm, while I am taking the algorithm playlist, that I will be just comparing two time complexity and doing some process in two time complexity so that I can check which one is efficient. For example, if I give you like n power 5 and 2 power n, and I ask which one is best, then you will be comparatively telling that n power 5, right? So in critical scenarios like whether log n or log of log n, which is smaller, then in this scenario I will be just taking some exponential or doing some logarithmic activities so that I can tell you that which one is smaller. So these all will be not covered in this data structure playlist, but it will be covered in the algorithm playlist. I will be just creating that soon, but now it is not necessary, and this thing is going to be much more important. This order, remember this. Try to remember this order. Okay, this is going to be crucial. Hope you understand this entirely. And I want you to do some homework on just see this graph. See this graph. Okay, like in Google, just search for time complexity graph. Then you can have some graphs like for O of n, this will be like this, and for O of 2 power n, this like this. For O of n square, sorry, n factorial, then it will be like this. The graph with respect to time complexity, with respect to inputs. Sorry, so here comes input, and here comes time complexity. Okay, so just see this graph in Google so that you can understand how this entire things will be graphed in a 2D graphical manner or graphical representation. So hope you understand everything, and I don't want you to make the same mistake like time complexity and space complexity are the one which decides the algorithm is best. No, it is some metric for personal computers. Okay, and also I don't want, sorry, I want you to clarify that time complexity is not time taken, is rate of time with respect to the given input. Okay, so hope you understand everything in this video. If you really like this video, and subscribe to my channel. Don't skip any videos in this playlist because all videos will be helpful once you are going for the competitive programming or problem solving. And if you have any doubts, just ask in the comment section. I will be giving you a separate video, or I will be just giving you a clarified answer in the comment section. Thank you.